Video 5. Cognitive Products, Some Basic Ideas. This episode, just like all other videos in this series, is about cognitive patterns which are more general than mathematical concepts. The cognitive schemas reflect the everyday use of human concepts. These rudimentary patterns constitute the basic building blocks of more complex expression such as those found in language, mathematics, and science in general. The word product is used in everyday language, biology, physics, chemistry, mathematics, business, economy, management, and in many other specialized disciplines. In mathematics alone, the term appears in many fields including algebra, geometry, matrices, sets, topology, and so on. They all seem to express the same underlying pattern. The way the concept is used may vary from discipline to discipline, but all those ideas are close enough to justify the use of the same term. What is this pattern? The analysis of diverse uses of the term product suggests that the concept combines two distinct ways of reasoning depicted in the animation below. One involves repeating the unit within itself, which emphasizes nesting. The other requires the unit to be repeated as a single indivisible whole, which emphasizes extent. The Droste-type pictures are very convenient for differentiating nesting from replication, but they are difficult to use in the visualizations of products, which are best explained by means of levels. They exhibit the same nested structure as the Droste images, which is demonstrated in the animation below. Referring nested levels to the base simplifies their representation and makes the use of containers for replication possible. There is one thing left to do. Water levels in all regular containers could be interpreted in two ways: as a stack of discrete elements or as a nest of scales. To interpret water column as nested levels, its representation has to be modified in the way depicted in the next slide. Instead of the level lines, let us emphasize the volumes denoted symbolically with the nested rectangles. To see that they are nested, the rectangles are shifted sideways. This creates the overlap which suggests that the volume 3 contains volume 2, which in turn contains volume 1, which contains volume 0, standing for the empty vessel. Even though they look different, all three depictions represent the same concept of nesting. From now on, they will be used interchangeably. The notion of product combines the sense of nesting within the unit with the replication of the unit. Because the two concepts are orthogonal, as different as they can be, they are typically depicted on perpendicular axes, with the vertical axis standing for the nested aspect and horizontal one for all multiples of the unit. The animation below shows the transition from Droste nesting to the equivalent forms of nesting associated with the concept of levels found in many notions, including those of liquids, various types of intensity, and values. The reference to the base of nested rectangles emphasizes the sense of accumulation associated with each additional level. Level 0 stands for an empty container, an energized sensor, or valueless objects, etc. To appreciate the notion of products better, we have to consider the notion of sum first. In the example below, the water in the puddle is transferred to the container. The container with water is the sum of two entities existing at the same, larger scale, which makes adding them possible. Both addends and their sum are public, that is, they can be observed by all people around them. However, as soon as the water is considered in terms of levels, other scales are introduced which are not accessible for the observation by the public in the larger scale space. As a result, the sum of addends changes into the product of factors, one of which is private, levels, and the other public, repetition. All products combine together the related private and public experiences of the individuals engaged in observing objects or expressing their own thoughts. Consider a unit with one scale only. As a level, the surface of water is public. Such structures could be considered as either the sum of two addends of the same scale, or as the product of smaller scale with larger one as depicted below. As such, products combine smaller scales of the unit with the larger scale of its repetition. Let us start with one repetition of a unit, for example, container of water. In this context, zero repetition of the unit amounts to the absence of the container, and with it the absence of levels and product. Note that the absence of repetition does not mean that the product equals zero. It means no product. It does not matter how many scales the unit has. If it is not repeated at all, none of those scales will be replicated. In the absence of the larger scale, the small scales and with them the product cannot exist. Because of this, the expression 4 times 0 does not make sense in the context of product. The same happens if the unit has the zero level of intensity or value, which, in this case, stands for empty container. Not repeating empty containers result, as before, in no product. No container also means no concept of the zero level. On the other hand, the formula 0 times 1 makes a lot of sense because 0 stands for no intensity or value, or, in this case, for an empty container. Containers without water can be replicated as easily as containers with water. Let us multiply an empty container one time only. What would be the product after the multiplication? 0. Product equals empty container repeated one time equals 0 times 1 equals 0, that is empty container. This means that emptiness cannot exist without a container of some kind, and the sky is black not only because space is empty, but more directly because light has no intensity. One can repeat empty containers, unenergized sensory cells, or objects of no value as many times as one wants to, and the product in all such cases will remain 0. This is important, as it means that 0 does not stand for nothing or a place value in a positional notation. Just like any product, 0 too has an extent. It expresses all unique associations between levels, intensity, values within a unit and its repetition. In essence, products are all unique associations between levels, intensity, values within a unit and the repetition of a unit. If a unit with 4 scales is repeated 4 times, the total of unique associations is 16, hence 4 times 4 is 16. Because the level 0 is not a level as such, as it stands for an empty container in this case, its intersection with the repetition lines is not treated as an association. From the sensory perspective, objects do not exist in isolation. They are located within their respective backgrounds which, just like objects, are products. It is the intensity or value of a quality which makes objects prominent. This means that there are as many backgrounds as the object has qualities. Products represent objects, qualities of some intensity or value, in the context of contrasting backgrounds, for example, units of no intensity or value. This means that 16 is not just the product of 4 multiplied 4 times, but the sum of 3 products, 2 of which are, in the example below, the empty containers. The concept of product presented in this video can be generalized in the context of any property or quality in the following way. Product equals intensity times extent of a property or quality. The product is a positional schema in which the first factor is always interpreted as intensity and second factor as the extent of intensity. This means that in the case of 3 times 4, 3 stands for the number of nested scales or levels within the unit, and 4 is the repetition of the unit with its scales. If the factors are reversed as in 4 times 3, then 4 represents the number of scales and 3 the extent. The notation 3 times 4, 4 times 3, 2 times 6, 6 times 2, 12 times 1, and 1 times 12 represent the same product, where 12 times 1 stands for the unit with 12 scales, and 1 extent, intensive representation of the product, and 1 times 12 stands for the unit of 1 scale repeated 12 times, extensive representation. The properties of products and their relation to sums, hence the relationship between multiplication and addition, is described in a separate video. All ideas in this video come from a book published in 2014 under the title Conceptual Understructure of Human Experience. The book can be purchased from Amazon.